Hello, my name is Preethi, TRBEEE Padikalam Vanga. Today we are going to see the set of 5 questions based upon the magnetic circuits. The first question is, how much energy will be stored in the magnetic field of coil which has self-inductance of 15 millihenry and a current of 40 amps? The 4 different options are given to you. So we know that inductor is a component which used to store the energy in a magnetic field. So before that we should able to understand the formula like the energy stored in the magnetic field. E is equal to half into L into I square. L is self-inductance and I is the current flowing through it. So L is given to you as 15 millihenry, 15 10 power of minus 3 and I is 40 amps. So 40 square I have written. So better we can write 40 into 40. Just evaluate, 20 times 2 will be 40. Am I right? So 15 into 10 power of minus 3 into 800. 4 2s are 8, 2 zeros are there. 15 8s are 120. So 120. Again you can add 2 zeros. 10 power of minus 3 means I can write by 1000. So 3 zeros gets cancelled. Your answer will be 12 joules. Am I right? And the next question is ampere per turns per unit length of each part of a magnetic material depends upon the dash. We will be having the 4 different options like thickness of the laminations, frequency of variation of voltage, working flux density, volume of the magnetic material. So magnetic field strength, it means that it is otherwise called as what? Ampere turns per unit length. The magnetic field strength means what? So we know the formula like B is equal to mu H. Am I right? B is equal to mu into H. B is equal to mu H and H is the magnetic field strength and B is the magnetic flux density. Mu is equal to mu naught into mu R. Mu naught is the permeability and mu R is the relative permeability. Am I right? Mu naught is the absolute permeability and mu R is the relative permeability. So the magnetic field strength depends upon the magnetic flux density, we can say. So among the 4 different options, I can able to select the option number C as the magnetic working flux density. And the third question is, the typical values of leakage factor were approximately equals to dash. They have given you the 4 different options to us. So the leakage flux means it is always represented to be as lambda. Okay. Leakage flux means what? The magnetic flux which does not flow through the particularly intended path in a magnetic circuit, that we call as leakage flux. So here the leakage factor, what is the statistical data? That we can take it as 1.12 to 1.25. So these questions may ask in the competitive examination. So please make a note of this. The 4th question, the force experienced by a current carrying conductor lying parallel to the magnetic field is dash. So 0, BIL sin theta, BIL cos theta, the 4 different options were given to you. Yeah. So நம்மளே படிச்சிருப்போம். B படிக்கச்ச F is equal to BIL sin theta. Am I right? இது நம்ம படிச்சிருப்போம் because evaluate பண்ணோம் பெரிய ப்ராசஸாக போயிட்டே இருக்கும். But here வந்து parallel is given to you. இப்போ parallel அப்படின்னா in the case of theta no, you please apply 0. அப்போ sin 0 is 0, the value of F becomes the 0. Am I right? F is the magnetic force, B is flux density, we know all the things. So theta இருக்கிற இடத்துல நம்ம 0 apply பண்ணிங்க அப்படின்னா the force experienced by a magnetic field lying parallel is 0. Option A is correct. The 5th one, the maximum possible mutual inductance of 2 inductively coupled coils with self inductances L1 L2 is given to you. We need to find out what are nothing but M வந்து கேட்டிருக்காங்க, mutual inductance வந்து கேட்டிருக்காங்க. It depends upon the coefficient of coupling K சொல்லுவோம். M is equal to K into root of L1 into L2 கேள்விப்பட்டிருப்போம். In this case K is not given to you. அப்போ 1 நீங்கள் எடுத்துக்கோங்க. In the values of L1 and L2 are given to you, no? Just substitute it. That is 6 into 100. So root of 3600 which is equal to I think 60 millihenry is given to you, no? 60 millihenry will be the answer for this. So thank you my dear friends. Please like, share and subscribe. Thank you.